Remember what we said when it comes to our function g. How do you know that the function g of x, which you have or which you have come up with, is the one which is going to lead to convergence or not? So the first thing which you're supposed to do once you have your function g, then of course this particular function g, you need to work out what the derivative of this particular function is. Then the other thing we're saying is that this particular function g and the derivative g of x are supposed to be continuous in some interval ab. So basically you're looking for the fixed point in a particular interval ab. And this particular fixed point, where it is, if you still remember if you go back to the first notes, where we talk about what a fixed point is, when you said the fixed point is a value p, where you get this p, you put it in the g of in the function g, then it gives you back p. Then there is another sentence which you didn't focus on, which said that geometrically, okay, if you are to draw where the fixed point is going to be, I'll do that. I think let me just do that. If you are to draw where the fixed point is going to be, okay, I'll share this tab for a bit. Where is here? This sentence here says that geometrically the fixed point of a function g of x, so if you have got g of x, so your g of x, we can say g of x is equal to y. So geometrically the fixed point g of x are the intersection points of g of x, y is equal to g of x, and y is equal to x. Now y is equal to x is just a straight line. This one here, y is equal to x, is just a straight line which passes through the origin of your xy plane. Are we clear?
Yes, sir.
Then this particular function is going to be some other, as you can see, it's going to be some function, but they are going to intersect between, there's going to be an intersection between this one g of x and this one y equals to x. So where they're going to intersect, that's what the fixed points are. So it's not everywhere where you can find these particular fixed points. Are we clear? If you can imagine, let's say for instance, you imagine a quadratic where your g of x is a quadratic function. Okay, then this quadratic function, some kind of a quadratic function, it's intersected by this particular line, y is equal to x. So your fixed point is not going to be all over the place. It's going to be only in those places where the intersection is happening. Are we clear?
Yes, sir.
That's why we are saying that your particular fixed point is supposed to be found only in a particular place. So for you to look for a particular fixed point, there has to be some you need to focus on a particular area. Basically, if I could say that, you need to focus on, I'm now changing it, like you need to focus on a particular interval where you think this intersection is going to be. Is that clear?
Yes, sir. It's good.
Yeah, so one of the things we could have done if we were using our computers, since we know how to use Python, is one of the things we could do is to make a plot of y equals to x and the other plot of g of x, so that we see where the fixed points are supposed to be, the points which will not change are supposed to be. Okay, so basically this is what we're saying in the morning. So your starting point, your x naught or your p0, your x0, your starting point is supposed to be a point which is in this particular bracket AB. And in this particular bracket AB, that's where the fixed point is supposed to be. And the fixed point is where your g of x meets the curve, the line y is equals to x. So basically what we are saying here is that if we had the benefit of a graph, you can choose your A and B so that your fixed point is between A and B. Then you start with any point x equals to 0, which is between A and B. So once you choose a point, your starting point, which is between A and B, then you work out what the derivative of this particular function g is. Then you find out what is the absolute value of the derivative for that particular value, any value which is in this interval AB. If the derivative, as we have seen, is less than 1, then in that particular case, this particular function is going to lead us to this particular fixed point, which is the solution to our problem. If, on the other hand, the absolute value of the derivative is greater than 1, then this particular function, which we have chosen as our g of x, will not lead us to this particular fixed point. So it will take us away. So what we have now, what we're going to do is we're going to look at an example in which we have got our function g of x and we have an interval. So we need to determine if this particular function which we have, g of x is equals to 1 minus x squared divided by 4 on the interval 0, 1 has got a fixed point. Is there where this particular function cuts the line y is equals to x? Okay, so as you can see, this particular function is some sort of a quadratic. You can see that there's x squared here.
Yes, sir.
Yeah, so this is some sort of a quadratic. Okay, so our suspicion is that our fixed point is somewhere in this particular interval. So in this particular interval 0, 1, we can choose any number which is going to be our starting value. Are we clear? As long as the number you're going to choose is going to be in this interval 0, 1. So the first thing we are going to do is we're going to work out the derivative of g of x. So the derivative of g of x is going to be, when you differentiate this, you're going to end up with g prime of x is going to be, this one is going to give you 0. Then here you're going to have minus 2x divided by 4, which is what you have here, minus 2x divided by 4, which is going to, which is going to give you, I think I made a mistake somewhere, anyway, which is going to give you, which is going to give you 2 divided by 4 here, so you end up minus x divided by 2. I think it's supposed to be 2 here. I think it's supposed to be 2 here.
Yes, supposed to be 2.
Yeah, supposed to be 2. So there's that other mistake. Let me just take note of that. So there's supposed to be 2 there. There's supposed to be 2. Okay. Then if we choose our x naught to be 0.5, so if our x naught is equal to 0.5, then we can work out what our derivative at x naught is going to be. So our derivative at x naught is going to be minus 0.5, right, divided by 2. So 0.5 divided by 2 is 0.25, right? It's going to be minus 0.25. Is that clear?
Yes, sir.
Yeah, so you're going to have minus
Yes,
0.25. So for minus 0.25, if you get the absolute value of minus 0.25, that's just going to give us 0.25, which is going to be less than 1. Are we clear?
Yes, sir.
So what
Okay,
what we're seeing here is that the derivative of our function g of x in this particular interval, if you choose anything in this particular interval, is going to give you a value which is less than 1. If it gives you a value which is less than 1, then that simply means that there is actually a fixed point which exists in this particular interval 0, 1. Okay. So now that we have through this step confirmed that there is actually a fixed point which exists in this particular interval 0, 1, then we can start doing our fixed point iteration to find out what this particular fixed point is supposed to be. So in that case, when you do that, so our function is g of x is equal to 1 minus x squared divided by 4 on the interval 0, 1. So our fixed point iteration formula is, so we're going, this is our g of x. So we're going to say, using our g of x, we are hoping to get, if you put in our whatever x0, we get x1. So our iteration formula is going to be x k plus 1 is equals to g xk. So in this case, our g of xk, or whatever it is, g of x is what we have here. So where there's x, you put a k, so you end up having this thing here. We end up having x k plus 1 is equals to 1 minus x k squared divided by 4. So this becomes our iteration formula. Fixed point iteration formula. Is that clear?
Yes, sir.
Okay, so with that formula, well, now we can start with x naught equals to 0, which is what we started with. For x naught equals to 0, so for k equals to 0, this formula, x k plus 1 is equals to minus xk squared divided by 4 is going to become x1 is equals to 1 minus x0 squared divided by 4. So in this case, if you put your x0 which is 0.5, you put 0.5 there, so you end up having 0.5 squared divided by 4, then minus whatever it is, we're going to end up with x1 is equals to 0.9375. Then for k equals to 1, our fixed point formula becomes, fixed point iteration formula becomes x2 is equals to 1 minus x1 to the power 2 divided by 4. So our x1 is this one which you have here. So if you put our x1 here, we end up with 1 minus 0.9375 squared divided by 4. So you're going to end up with x2 equals to 0.780273,437. Okay. Then for k equals to 2, our iteration formula, our fixed point iteration formula becomes x3 is equals to 1 minus x2 squared divided by 4. So our x2 is what you have here. So you put in our x2 here. So you end up with 1 minus this squared divided by 4. So you end up with x3 equals to 0.84779,384. So first, there was a change in all the numbers. With the 0 has remained the same. So the 0 has not been changing. The 9, the first digit after the decimal point, has been changing. So it was 9 here, then there was a 7 here, then it has become an 8 here. Okay. Then for k equals to 3, our iteration formula, x4 becomes 1 minus x to the power 3, 1 minus x3 to the power 2 divided by 4. Then we put in this value of x3, which we have, squared divided by 4. So we end up with x4 being equals to 0.820311618. So one of the things which you see, which has started to happen, is that the x, the 8, the first digit has stopped changing. This 8 is what you also have here. So the 8 has stopped changing. You see that?
Yes, sir.
Yeah. Then we move on for k equals to 4. So our fixed point iteration formula becomes x5 is equals to 1 minus x to the power 4 squared divided by 4. So you end up with x5 is equals to 1 minus this value of our x4 squared divided by 4. So you end up with x5 is equals to 0.831772214. So you can see the 8 is there. So basically, it has stopped, the first digit has stopped changing. So basically, you start getting the sense that your fixed point must be somewhere 0.8 something. Is that clear?
Yes, sir.
Yeah. Just a minute. Then for k equals to 5, our fixed point iteration. Just a minute. Oh? Okay. Could you put that on? 17. Then what about this? How do you move the guy? 5. Okay, look at one. Then I think we'll try to see if you know how to get much ticket around. Okay. Okay, so for x4, so we have our iteration formula becomes x5 is equals to 1 minus x4 to the power 2 divided by 4. So our x4 is what we have here, 0.820313 311612. Then we put in this whole thing here squared divided by 4. So we end up having x5 is equals to 0.831772114. Then for k equals to 5, our fixed point iteration formula becomes x6 is equals to 1 minus x5 squared divided by 4. So we end up having x6 is equals to 1 minus 0.831772 squared divided by 4. So you end up having x6 equals to 0.827038745. Take out. Then for k equals to 6, okay, for k equals to 6, our fixed point iteration formula becomes x7 is equals to 1 minus x to the power 6, x6 to the power 2 divided by 4. Our x6 is what we have here. Then when we do the substitutions, we end up with 1 minus 0.827 as 0.63714 squared divided by 4. So you end up with this. You end up with 0.829001728. So one of the things you notice is between x7 and x6 is the 2. Have you seen that the 2 has stopped changing? This. So now you have got x6 is equals to 0.82. Then here at x7 you have got 0.82 also. So the 2 which you have here has stopped changing. So basically now you have a very good idea of where this fixed point is, somewhere 0.82. Okay. Then you proceed for k equals to 7. So your fixed point iteration formula becomes x8 is equals to 1 minus x7 squared divided by 4. So when you put your value for x7 there, so you end up having 1 minus 0.829001728 squared divided by 4. So you end up with x8 equals to 0.828189033. So basically you can see these two numbers are now firmly in place. The 0.82 is firmly in place. So the question is whether the next number, the 9, how much is it supposed to be? Is it 9? Is it 8? Is it whatever it is? Okay. But we have a very good idea of where it is. It's 0.82. Is that clear?
Yes, sir.
Yeah. So for k equals to 8, our fixed point iteration formula becomes x9 is equals to 1 minus x8 squared divided by 4. So when you do this, you end up with x9 is equals to 1 minus 0.82819189003 squared by 4. So you end up with 0.8298285255713. So the other thing you notice here again is our 8, which we have here as a third digit, is the same which we're having here. So it's between somewhere 0.828 or 829, somewhere there. Then we move on for k equals 9. So for k equals 9, when you do that, you end up with k equals 9. So your iteration formula becomes x10 is equals to 1 minus x to the power 9 squared divided by 4. If you do that, you end up with x10 is going to be 1 minus 0.828 525,713 squared divided by 4. So you end up with x10 equals to 0.828386278. So what you see here is that the first 3 digits after the decimal place are now fixed in place. So we have a very good idea of where this fixed point is. Are we clear?
Yes, sir.
Yeah, so you could basically approximate, say your fixed point should be 0.83, somewhere there. Or if you just want to leave it as 0.83, 828, then that's also fine. If you want to express your fixed point up to decimal places. So basically, this is how this process works. This process of what's it? This process of iteration. When you do iterations, this is basically what you mean. This is what you're supposed to be doing. Are we clear?
Yes, sir.
Yeah. Now, the reason why we're trying to do this is because right now, if you see what we have done, we have just created an iteration formula for only one function. But if we are to do the things which we want to do, which is to solve for systems of linear equations, these systems of linear equations usually tend to be more than one equation. And these equations have got many unknowns. Okay, maybe 2 unknowns or 3 unknowns. But the rule is, when it comes to working out systems of linear equations, is that if you have a certain number of unknowns, let's say you've got 3 unknowns, it means that you need to have 3 equations. Are we clear?
Yes, sir.
If you've got 5 unknowns, you need to have five equations. Now, what we are going to do when we meet next week is we are going to extend this idea of fixed point iteration. We are going to extend this idea so that we can solve systems of linear equations at once using this iteration stuff, where we are going to start out, let's say if we have got 3 equations with 3 unknowns. So for each of these 3 equations, we are going to create a function which is going to give us a value of x, like we're going to create a g of x. But since these are going to be equations of certain number of unknowns, so we are going to create functions, most likely which are going to be either functions of 2 variables. So we are going to create x is equals to a function of, instead of g of x, is going to be x is equals to a function of we can say what, f of y and z. Then we create another function, an iteration thing, y is equals to a function of x and z. Then we create another one, z is equals to a function of x and y. Then we're going to do this process we have gone through with starting with some guess values. So you're going to start with some guess values. X naught is equal to this much, y naught is equal to this much, z naught is equal to this much. Then we'll be putting in these values and generating other values which you're going to put back into these formulas. They will generate other values which you're going to put back into these formulas, and they'll generate other values like that. Eventually, the things which are going to be getting, our values are going to be heading towards some fixed positions. All 3 for the x value you're looking for the y value you're looking for the z value you're looking for, all these 3 are going to be approaching some fixed point values at the same time, like the way we have done it here. So what we have done here is how to work out a fixed point, how to find a fixed point using just a function g of x. So when we meet next week, we're going to extend this idea of iteration so that we can solve our systems of linear equations. Okay, in the meantime, between now and next week, I'll put together a small program which does fixed point iteration. And in this particular program, if you give it a function g of x, then you give it a starting value, then this particular function should be able to work out what the fixed point is quickly. Are we clear?
Yes, sir.
Yeah. So we are going to meet next week. Tomorrow we are not meeting. Wednesday, of course, well, I need to take the baby to the clinic, so we're not going to meet on Wednesday also. So the only time we're going to meet is next week, since Friday is a holiday. It's a 9-working holiday. Yeah. All right. Thank you very much. So see you next week.
Thank you, sir.
Cheers.